Okay, geometry, welcome back again. This is section 3.2, talking angles and parallel lines. All right, the objective in this section is to use theorems to determine relationships between angles and then also use them to set up algebra problems. The big difference here between this section and section 3.1 is that now we're going to be talking about parallel lines cut by a transversal. Before with the transversals, they were just cutting any two lines, and we got our angles relationships. Now we're going to take a look at those relationships and what happens when they're parallel lines that the transversal is cutting. So you can see right here that this definition, all of them are going to start with if two parallel lines are cut by a transversal, blah, 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 okay? So, for example, the first one would say if two parallel lines are cut by a transversal, then we go down here to corresponding angles postulate. If two parallel lines are cut by a transversal, then we would say that corresponding angles are congruent. So we'd say corresponding angles are congruent. Okay? So that would tell you in our example here that when we look at these, we'd say like angle 2 and angle 6 would be an example. They're corresponding angles, so they would be congruent. Angle 2 would be congruent to angle 6. All right. What else could we do with that knowledge? One thing would be if we knew that, and we'll get to this later, but if we knew that angle 2 was, say, x plus 5, and angle 6 was 5x minus 13, well, then we could set those two equal to each other and solve an algebra problem based on that. So we'll use that information later on to find out what x is, and essentially we'd be able to find out what the angles were worth. Okay? The next one, if two parallel lines are cut by a transversal, then alternate interior angles, as we get to this theorem, alternate interior angles are also congruent. So alternate interior angles are congruent. So an example here would be 4 and 5 would say. Angle 4 and angle 5. Angle 4 would be congruent to angle 5 because they're alternate interior angles and the lines are parallel. I can't tell you how much that matters. If they're not parallel, then we can't say they're congruent. But if they're parallel, then we can say that they're congruent. The next one's the only one that's different. So far, you're noticing a pattern. They're all congruent. This one is one of the only ones that's different with this relationship. So this relationship tells us that if two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. So consecutive interior angles are supplementary. Okay, what does that mean? What does that mean? Again, that means they add to 180. It means they add to 180. So if we look at the diagram here in the example, we look at, say, angle 3 and angle 5, those would be consecutive interior angles. Those two would add up to 180. So they're not congruent, they're supplementary. So we would write angle 3 plus angle 5 equals 180 would be the equation we could come up with there. Okay, a couple more because there's another angle relationship we haven't talked about yet, and that's alternate exterior angles theorem. And again, this one's just like the first two, in that if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. So most of them are congruent. 3 of the 4 relationships that we've discussed are congruent. The only one that's not are consecutive interior. They are supplementary. So this one here, alternate exterior angles, if we looked at, say, 1 and 8, they're exterior angles. They're alternate on opposite sides of the transversal, so they would be congruent. So we could say angle 1 is congruent to angle 8. All right? And the last theorem here, if two parallel lines are cut by a transversal, then we can also say that in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other line. Okay? So we can see an example here. You can see right in here. Since it's perpendicular to line N, it would also be perpendicular to line M. So if they just gave us one of them, then it has to be perpendicular to the other. That makes sense for a lot of different reasons. Number one, it would be corresponding, right? This angle would correspond with this one, so they have to be equal. So if this one is, if this one here is 90, then this one also would have to be 90. And there's a lot of different ways you can do that with alternate interior and alternate exterior angles as well. Okay? All right, let's move on to some examples where you're going to find, they give you one angle and you're going to find the measures of the other angles. And we haven't talked about this yet. I don't know if we have in chapter 1, but the M here, that means measure. They're just looking for the measure of the angle. Okay? So if we haven't done that yet, that just means measure. Okay? So in the figure here, it says measure of angle 11 is 51 degrees. So I'm going to say this one is 51. Find the measures of each angle and tell which postulates or theorems you used. Okay? So they are asking for the measure of angle 15. So 15 is right here. Okay? So what relationship does that have to 11? Well, it's a corresponding angle, right? It's above line X and Y, and it's to the right of the transversal Z. So that would have to have the same angle, right? Because corresponding angles are congruent. So it would have to be 51. If we look at letter B, the measure of angle 16. Well, 16 is down here, okay? What's the relationship with 16 and 11? 11 is here, it's 51. And 16 is on the alternate side of Z. It's on the opposite side of Z, so we know it's alternate. And it's on the outside of lines X and Y, so it's an alternate exterior angle, so it would also be 51. Another way you might be able to tell that is that it's vertical with angle 15. So if it's vertical with 15, it's got to be equal as well, or congruent as well. All right? And the last one they're asking for here is angle 10. Well, angle 10 and 11, what's their relationship? Well, there isn't one that we've talked about, but they do form a linear pair. Angle 11 plus angle 10 would make this straight line, so it would have to be supplementary, so we would say that it's 129 degrees. 129 because it has to add to 180. And you could actually fill in the rest of them based on all the theorems we know. Okay? We also know we could fill in 12 because it's vertical to 51. 12 would be 51 because it's vertical. 13 then would be 129 because it's vertical with 10. It's also a consecutive interior angle with 15, so it would have to add to 180. 14 and 12 are consecutive interior angles, so they're supplementary and would have to be equal to 180, so that would have to be 129. And the same thing with 17, you could say 17 and 10 are alternate exterior, so they would have to be equal. So you can see that whole diagram, we could fill them all out, and you've only got two answers, 51 or 129. Okay? The next one. Let's just do number 3. We can work on number 2 on your own once we've done number 3. Again, we see the parallel lines. They're shown by these arrows here. That tells you that they're parallel. And so we can use our angle relationship theorems. So we're going to find x and y here. So let's start by finding x. Okay? Actually, I think we got to start with y because we only have one x here. We've got two y's. So let's look at the relationship between these two angles. You got this angle here and this angle here. What is the relationship? Well, they're both inside those two lines, so they're interior angles, and they're on the same side of the transversal. So they would be alternate interior, or excuse me, they would be consecutive interior angles. Same side means they're consecutive and interior of the two lines. So because they're consecutive interior angles, And I guess one way we just make sure we're pointing out the same stuff. We're talking about this one and this one here. These are the two things we have to use because they both have y's, okay? They both have y's. So if we look at that and say that their relationship is that they're consecutive interior angles, well, what that does is it tells us that they are supplementary. So because they're supplementary, they're going to add to 180. So I can take those two expressions, 8y plus 2, add it to the other one, 25y minus 20, and set it equal to 180. And then I can kind of solve from there. So when I do that, I got terms I got to combine. I got an 8y and a 25y. That's going to give me a 33y. And then I've got a 2 and a negative 20 is going to give me a negative 18 equals 180. Then, of course, I'm going to add 18. So I'm going to have 33y equals 198. And then when I divide by 33, I'm going to get y equals 6. Okay? So I have y equal to 6. So that's one way. That's the way to solve for y. Now we have to get x in there. So we can use a couple different things, but let's take a look at what x's relationship is with one of these expressions. So if I take a look at it, I could say, well, I know that they have to be supplementary with one of these expressions. So let's take a look at these, and let's say, what relationship does this angle here, 10x, have with this one? Well, together, they would make a linear pair. So I would say they're supplementary, so then I can go ahead and do that math over here. Okay, so because these two are supplementary, because they would make a linear pair, I can say that 10x plus 8y plus 2 equals 180. Let me rewrite that here. Okay, but now we got two variables here, and that's a little bit troubling. But we do know what y is. We found y down here to be 6. So I can plug a 6 in here and say 8 times 6 is 48. So I can actually rewrite this by plugging in that 6 right here and saying, well, now I know that it's 10x plus 48 plus 2 equals 180. And now I can do the algebra from there. I know that 48 plus 2 is 50. So I'm going to have 10x plus 50 equals 180. And then I'm going to subtract 50. So I'd have 10x equals 130. And then when I divide by 10, I get x equals 13. So when all was said and done, I have my answers of x equals 13 and y equals 6. Okay? Another way to do that would be to take a look at this relationship here between the 10x and the 25y minus 20. What is their relationship? Well, they are both alternate interior angles. They're interior, but then alternate sides. So you could have set those equal to each other and done it that way. You might have liked that way a little bit better. Okay? But just another way. There's more than one way to solve that problem. So work on number 2 the same way. Find the relationship between two angles, and then try to solve for x and y. And then the same thing here with number 4. Number 4 is the same deal. We're going to have a problem, a bunch of different angles here. They give you the measure of angle 5 being 2x minus 10. Measure of angle 6 is 4 times y minus 25. And 7 is x plus 15. They want you to find x and y. So you can go ahead and write them in this diagram and check that out. Okay? All right. I think that's about as far as I want to go. There is some other information that we can give you that I will give you tomorrow in class that maybe we can put on note cards. But as far as this part of the lesson, we'll be done with it today. So try to work on number 2 and number 4 on your own. Try to do that. If you struggle with it, that's okay. We'll handle it tomorrow or the next day in class, and we'll deal with it. Okay? Until then, that's it for section 3.2, and we will see you next time.